Now that we find some of the features that was important through permutation importance, maybe sharp importance, and our normal gradient boosting regression algorithm, now you can use any of those algorithm and create the importance values in the descending order. So here I use the algorithm that is gradient boosting regression algorithm, and using this algorithm I calculate the feature importance and I have sorted them into the descending order. That means those attributes or the features that had the high importance will be at the top. So you can see origin has the high importance, arrival hour has the second high importance, and the list was that is DEP minute. These are least important and the upper values are higher. That means they are most important attributes. Now in this video we are going to select those features that are only important, and this is used in order to select only those important feature and reject those features that are not important. And it is useful concept to do in any data science project in order to optimize our algorithm. So here I found the importance, and the importance was found through gradient boosting regression, and we have already seen about this. And here in the gradient boosting regression, it is an ensemble technique which uses concept called as a tree and the Gini importance to find these importance values. Now here I'm going to create a feature list which has the value of importance greater than the threshold that I have defined here. So this threshold can be different based on the situation that the project demands. In my case, I have assigned 0.005 is the threshold. So if the importance is less than this, I'm going to reject those features. For example, in our case, these features like this one has the value that is lower than 0.005. So I'm going to just remove everything that has been selected here, and I'm going to keep those features above it. So that is what this line will do. So this is going to just sort it out first, and after that I'll just get the feature from here. So these features I'll select it, and I'm going to convert it to the list so that I can have the list with all of these features. Now from here I got the feature list. You can see this is my feature list, and now I can train the model further using only the feature list that I have selected. Now I will remove all the others. I won't be using this for my machine learning algorithm anymore. I will be only using those data or those features that I have just selected by performing feature importance. I'm using the Gini importance here. You can use any importance value using any concept. Maybe you can use permutation importance. You can also use SAP values, but here I'm using the Gini importance, and I just sort out the train and testing, which is new now because the feature list has been diminished here, because the feature list has decreased now in size. Initially we had all total that is around 20 plus features. Now we have only reduced to 5 features. See here, and we found how unimportant and irrelevant these features were. So this way you can just define the threshold. Based on this threshold you can either select or reject the features, and this threshold is completely based on your project preference. So this way we just select the new feature list. We again run the model. Now you will find that the accuracy will not change that much. That is the importance of feature engineering, because clearly if you go up with all the data, your RMSE was this value. Now we again train the model. Now in this case we only train with the 5 columns. Instead of all the 23 columns, we only use the 5 columns. And even in that case, our RMSE has not been increased. It is quite same. So that means we reduced the size of using all the columns. We reduced the complexity of the model. Previously, we had to use all of these columns and we got the RMSE. Now we use only some part of it, and even we got the RMSE that is even better to that. So that means adding all the columns are sometime not necessarily will increase the model's efficiency. Rather, it can degrade the efficiency. So that is the reason you need to handle the feature selection algorithm before training your algorithm. So create a model where you can select features that are important and use that only selected important feature for model building. So in that way, you can increase the accuracy of your model, you can decrease the complexity of your model, and you can easily make your model more readable and can be easily elaborated to non-technical person also. So that is all in this video, and these are very important concept. I'll see you in the next one.